This video is for the Blended Algebra 2 course, Domain and Range Practice number 2. We're going to do 3 questions from this practice. If you need help on any problems other than the 3 that are on this video, you need to check the key that's posted on Canvas or ask your teacher for help. Alright, so we're going to decide whether this graph is a function and then determine the domain and range. So here I have a linear graph. I'm going to check if it's a function first. And remember, you always want to check using the vertical line test. So if I drew a vertical line through this graph, it would only cross one time. That means it passes the vertical line test, and this graph is a function. Now when I do my domain, you need to remember that the domain deals with the inputs, or the x values. So you want to go all the way from the left end of your graph, which is over here, to the right end of your graph. Now on the left, farthest to the left here, that x value is at negative 1, 2, 3, 4, 5, 6, negative 7 with a closed dot. So when you write negative 7 down, you're going to put a square bracket with that value. Your graph covers all the x values from negative 7 until you get to x equals 5. Now 5 has an open dot, so you're going to fill it in with a parenthesis. When you look at the range here, you have to go bottom to top. The lowest y value has a closed dot, and that's at the y value of negative 3. Closed dot gets a square parenthesis, square bracket, I'm sorry. And the highest y value up here is an open dot at y equals 1, which will also give you a parenthesis. All right, the next problem. We first determine if this is a function. Because this graph, anywhere I draw a vertical line, will only cross the graph one time, it is a function. It passes the vertical line test. Now the domain here is my x's from left to right. When I look at the ends of this graph, I see an arrow going to the left. Hey guys. See an arrow going to the left. And that arrow going to the left is going towards negative infinity. Remember that negative infinity gets a parenthesis in interval notation. Now on the right-hand side, I also have an arrow that is going. That arrow is going to the right forever, which means it's heading towards infinity, which also gets a parenthesis. So this means that your domain encompasses all real numbers. Any negative and any positive things you want, you could put into this function. Now the outputs you could get from those x values, the range, are your y values. You always start at the bottom. The lowest y value you can get happens to be here at negative 1, 2, 3, 4, negative 5. There's a value there at negative 5, so it gets a closed square bracket. Now when I look at this graph, as I go up, there are arrows on either side. Those arrows are both heading up in the positive direction forever, which means the graph goes up towards infinity forever. So you can take any input, any real number, and put it in for the x. The y values would have to be negative 5 or greater. All right, one more problem here. This is another one of those with sets of ordered pairs. I'm going to darken the ordered pairs in for you. First, we need to decide if this graph passes the vertical line test or not. So when I draw a vertical line through each dot, those first 2 look like it passes. But when I get to this third one, see how that vertical line passes through 2 points? That means that it fails the vertical line test, and you are not a function. So I'm going to have to, there we go, I'll rewrite it now. So this was not a function because it fails the vertical line test. My domain, we did this in practice 1 and in the notes. It is not a continuous function because you cannot connect those dots with a straight line. So what we need to do is we're going to list out the ordered pairs that are on the dots. The first one's at negative 3, negative 4. The next dot up here is at negative 2, 5. Then I have 2 dots over here, one at 1, 3, and one negative 2. Once I write out those ordered pairs, it's a lot easier to see the domain. The domain uses x values. So I'm going to write down each x value from these set of ordered pairs. Because I'm not a continuous function, I need to use set builder notation for these. Remember, that has the curly bracket, the x, and the bar. So your domain is the x's such that x is only equal to -3, -2, and 1. I only have to write 1 twice because it shows up in the last two ordered pairs. The range is the same kind of thing. I want the y's such that y is only equal to these output values. -4, 5, 3, and -2. All right. If you need any more help on that practice, you need to check for the key on Canvas or ask your teacher for help.